Hello and welcome to this video about operations with scientific notation. What I'm going to do in this video is just simply go through some examples, so that way if you're a little uncertain about how to do this, you can watch, follow along, and perhaps pick it up as you go. I have other videos in which I explain the process in a more detailed format, but again, this is just about examples. So first example I'm going to go over is an addition one, where we have 2.5 times 10 to the 5th plus 1.3 times 10 to the 5th. With addition and subtraction, it's all about noticing this. Do we have the same exponent? And we do. This is pretty much locked in place until the very end, and usually will stay locked in place. So what we're going to do now is, at the very end, this is going to be times 10.5. What we do with these numbers is we do that operation, and we can do it off to the side. 2.5 plus 1.3. And that gives us 3.8. That 3.8 goes right here. And the way I like to sort of, rationalize this or explain it is if we were to, deal with slightly smaller numbers. So let's say 250 plus 130. This would be 380, right? And all we've done is we've rewritten these in scientific notation. And so like if we were to rewrite these in scientific notation, it'd be 2.5 times 10 squared plus 1.3 times 10 squared. And if we wanted to write this number in scientific notation, we'd get 3.8 times 10 squared. So we only really care about these digits, and we combine them. We do what the operation is telling us to do. And then we keep the scientific notation as is. Now, that's pretty straightforward. Let's kick it up a notch. Let's say we're going with 7.6 times 10 to the 6th plus 5.2 times 10 to the 6th. Okay, so again, we just check to make sure that we have the same exponents. We do, and those are locked into place. Our final answer, most likely, going to be 10 to the 6th. However, this one won't be. This one's a fun one. Again, we take this scratch work, or we take those and do some scratch work on the side. So 7.6 plus 5.2. And here we'll get 8 and 12. So 12.8 times 10 to the 6th. The problem, this isn't in scientific notation. That has to be one digit. So what we're going to do is bump this over one spot. And when we bump something over to the left one, that means we're going to add one here. So we moved this over one spot, this gets moved over one spot, or that gets added one more number. And the way to remember this is to use the acronym LARS. If you go to the left, you add to the exponent. If you go to the right, you subtract from the exponent. And so here we end up getting, as our final answer, 1.28 times 10 to the 7th. Now, let's do a subtraction example. So let's say we have 6.4 times 10 to the 7th, not plus, minus 3.9 times 10 to the 7th. So again, check, make sure we have the same exponents. We do. So that's going to be locked into place, 10 to the 7th, until the very end, maybe. And then do some scratch work with the subtraction here. So 6.4 minus 3.9. Turn this into a 5, make this 14. That becomes 5. 5 minus 3, 2.5. 2.5 times 10 to the 7th. Since this is scientific notation, or that's acceptable for scientific notation, we can box it and walk away. But now let's do something where it's not acceptable. Let's do something like 6.4 times 10 to the 5th minus 5.9 times 10 to the 5th. So we're good here. So our final answer is at least going to start with that. Do some scratch work, 6.4 minus 5.9, and what we're left with is 0.5. Uh-oh, that's not in scientific notation. So what we have to do is bump this over to the right one spot, and if we've bumped it over to the right, that means we are going to subtract 1 from our exponent, because Lars. We go right, we subtract. And so our final answer is 5.0 times 10 to the 4th. All right, one more adding and subtracting example. Let's say we have something that's 4.8 times 10 to the 3rd minus or plus 2.7 times 10 squared. Now we run into a problem. These don't match. We can make it match. We can go either way you want, although I'm going to suggest that you work with the smaller one. Again, we're going to use Lars, and so I'm going to make this into a 3. And in order to raise this up 1, that means I have to bump this over 1 spot. So the new problem is 4.8 times 10 to the 3rd plus 0.27 times 10 to the 3rd. Now, it's not written in scientific notation, but this matches up. And so what it does is it just changes what our scratch work looks like. And so what we're going to do is get 7, 0, 5. So our final answer will now be 5.07 times 10 to the 3rd. And again, the trick was picking up on the fact that these are different exponents from the get-go and changing it. And when you change the smaller one, you prevent having to change your answer. If you change the larger one, you'd have to you'd probably get 50.7, and so then you'd have to, make this, or change the exponent on the power of 10 to make it 5.07. All right, now let's talk multiplication and division. So let's say we have 6.3 times 10 to the 14th, and we're going to times that by 7.0 times 10 to the 5th. So what we do is combine these numbers. 6.3 times 7.0. And so what we're going to end up getting is, let's see here, so 1, spacing out, 44.1. I'm going to check that on the calculator. 6.3 times 7. All right, I feel good about that. Cool. Okay. That goes here, whoops, 44.1. Now, as for this, these guys get to play together, and we're going to use rules of exponents. 10 to the 14th times 10 to the 5th, we add our exponents. So 10 to the 14th plus 5 gives us 10 to the 19th. And there's our final answer. Finally, we'll do some division, and we'll just use the same numbers to keep life easy for us. 6.3 times 10 to the 14th divided by 7.0 times 10 to the 5th. So again, what we're going to do is divide these. So those guys play together, these guys play together. 6.3 divided by 7.0. We end up getting 0.9. So that would work out quite well. So 0.9, put the point there. All right, very good. And then over here, we'll go with 10 to the 14th divided by 10 to the 5th. And when you write it like this, it might be more obvious that you have to do rules of exponents, to where you subtract 5 from 14 to get 10 to the 9th. And so 0.9 times 10 to the 9th, and we're almost done. Can't do this. We have to use Lars one final time. And so we're going to be going to the right. So that means we're going to subtract an exponent. So move over 1 to the right, subtract 1, 9.0 times 10 to the 8th. And that is our final answer. So I went through a series of examples using scientific notation. I may have gone a little quickly, but if so, there's another video out there where I explain the process in a little more detailed. But this is just to show you, the process, how it gets done without having to over-explain everything else. So hopefully this was helpful, and let me know if you have any questions.